All right, 5.7 is the Pythagorean Theorem. The Pythagorean Theorem is the sum of the squares of the lengths of the legs that equals the square length of the hypotenuse. So remember, a squared plus b squared equals c squared. The c is always going to be the hypotenuse, which is the longest side and opposite of the right angle. So it's important which one you make the c squared. So example 1, find the value of x. Give your answer in simplest radical form. So how do we set up this equation? Equals what? What's our hypotenuse here? X squared. So now we need to solve for x. So it's 6 squared. What is 2 squared? And then we have x squared. So 36 plus 4? 40 is equal to x squared. How do we get x all by itself? Take the square root of both sides. So now we need to simplify the square root of 40. What can we break 40 into? 5 times 8. Can we break 5 down anymore?
No.
Can we break 8 down?
Yes.
2 times 4. So now we have 5 times 2 times 2 times 2. What pairs do we have here?
2.
We have a pair of 2's. So what do we get as our answer? 2 square root 10. So that's our length of the hypotenuse, 2 square root 10. Okay, let's look at example 2. Find the value of x. Give your answer in simplest radical form. So what's our a? X minus 2 squared plus, what's our b? 4 squared. And what's our c? So x squared. How do we do x minus 2 squared? What do we need to do? So this is like saying x minus 2 times x minus 2. So what do we need to do to multiply these two? FOIL. So we do the first terms, the outsides, the insides, and the last terms. And then we have plus 4 squared. What's 4 squared? 16, which is equal to x squared. So now we need to solve for x. So what can we do first to solve for x? Add the common terms. So what can we add together first? 2x and 2x. So that'll give us x squared minus, what's negative 2x minus 2x? Negative 4x. Can we add the 4 and 16? So plus 20 is equal to x squared. What can we do to get rid of these x squareds? What? Well, we can't take the square root because we still have an x squared on the left. We can subtract it. We can subtract them from both sides. So we can do minus x squared on the left and minus x squared on the right. So now what do we get? X squared minus x squared is 0. And then what are we left with the rest of the equation? Negative 4x plus 20 is equal to 0. What can we do next to solve for x? Subtract 20 from both sides. So we get negative 4x is equal to negative 20. What do we do next? Divide by negative 4. And what do we get for x? X is equal to 5. Any questions so far? Alright, so now we have something that's called the Pythagorean triple. The Pythagorean triple is a set of 3 non-zero whole numbers, a, b, and c, such that this is supposed to be a squared plus b squared is equal to c squared. It's called the Pythagorean triple. So in a Pythagorean triple, we're going to have 3 numbers. When a squared plus b squared plus c squared, we get 3 whole numbers. So like 3, 4, and 5. This is a Pythagorean triple that makes up the 3 side lengths of a triangle. What do you think are hypotenuses in a triangle that's 3, 4, 5? 5. The hypotenuse is always going to be the longest side. So in this one we get, what's 3 squared? 9. Plus, what's 4 squared? 16. So what's 9 plus 16? 25. So we're going to get 9 plus 16 is equal to 5 squared. The same thing will work for the other one. So 5 squared plus 12 squared is going to be equal to 13 squared. What's 5 squared? And what's 12 squared? 144. And what's 13 squared? 169. Great, Brooke. So 25 plus 144 is 169. So these are just common Pythagorean triples. So example 3 says, find the missing side length and tell if the side lengths form a Pythagorean triple. So we need to find the hypotenuse. So what equation can we set up to find the hypotenuse? So what's our A? 14 squared plus 48 squared plus, is equal to? X squared. What is 14 squared? 196. What is 48 squared? 2,304. And that's equal to x squared. On your guys' quiz, you're not going to be able to have a calculator, so you're going to need to know how to multiply big numbers. When's your quiz? Monday. So what's 196 plus 2,304? 2,500, which is equal to x squared. So what do we do next? Take the square root of both sides. So what is the square root of 2,500? 50. So we can break this up into 50 and 50. So now that we have a pair, we can take the 50 out. So we get 50 is equal to x. Do these three side lengths form a Pythagorean triple? Yes, because they are all whole numbers. That's what makes it a Pythagorean triple. If we found the hypotenuse to be like 5 square root 2, that would not make a Pythagorean triple. And the reason that makes this a Pythagorean triple is because we have three whole numbers. Any questions on this one? Ready to move on? Okay, example 4. Find the missing side length. Tell if the sides form a Pythagorean triple. Explain. So let's call this side x. What is going to be our c here? 12, because it's opposite of the right angle. So that 12 is our hypotenuse. So what's our a going to be? X squared. What's our b? 4 squared. And what's our c? 12 squared. So we have x squared plus, what's 4 squared? 16. And what's 12 squared? 144. So what do we do next? Subtract the 16. So we get x squared is equal to 128. So now we need to take the square root of both sides. So we get x is equal to, what can we factor out of 128? 2 and 64. What can we factor out of 64? 8 and 8. So now we have a pair of 8s that we can take out. So what do we get for x? 8 square root 2. So our sides of the triangle are 8 square root 2, 4, and 12. Do these three sides make a Pythagorean triple? No, because 8 square root 2 is not a whole number. So this is not a Pythagorean triple. Any questions? Right, next we have the converse of the Pythagorean theorem, which gives you a way to tell if the triangle is a right triangle when you know the side lengths. So if a squared plus b squared is equal to c squared, then we know that it's going to be a right triangle. So before we knew that if it's a right triangle, a squared plus b squared is equal to c squared. But now that we know a squared plus b squared is equal to c squared, we know it's going to be a right triangle. So this is the same thing as the Pythagorean theorem, but in reverse. We can also use the side lengths of a triangle to classify the triangle as acute or obtuse. So if a squared plus b squared is equal to c squared, it's going to be a right triangle. If a squared plus b squared is less than c squared, it's going to be obtuse. And if c squared is less than a squared plus b squared, then it's going to be an acute triangle. So for this, it's important to focus on which way the inequality is facing. So let's just look at obtuse. If the c squared is greater than the rest of it, we know it's going to be obtuse. Just think obtuse is the big one, so we need c squared to be greater than the rest of it. Okay? For acute, if c squared is less than the rest of it, we know it's going to be acute, because acute is less than 90. So let's do some examples. Tell if the measures can be the side lengths of a triangle. If so, classify the triangle as acute, obtuse, or right. How can we tell if it's the side lengths of a triangle? What do we need to do? Alexis, what do we do?
First, shouldn't we write out the equation first?
Well, this is telling us to find if they can be the side lengths of a triangle. What do we do?
We add the two side sides if it's bigger than the last, like the one that you didn't use, then it's a triangle, but let's do them alternately.
Yeah, so we add the two smallest ones, and we need them to be bigger than the third. So what's 5 plus 7? 12. So since it's bigger than 10, we know it's going to be a triangle. So now, Alexis, we can do the equation. So what is our a squared?
5 squared.
5 squared. What's our b?
7 squared.
7 squared. And what's our c?
10 squared.
How did you know that 10 was going to be the c?
Because 10 was the largest side, and the hypotenuse is always the longest side.
Right, so the largest side is the hypotenuse, so the biggest number has to be your c. So what's 5 squared?
49.
And what's 7 squared?
43.
And what's 100 squared? 10 squared? 100. So what's 25 plus 49? 74. Good job, guys. Is 74 equal to 100? No. So we know this is not a right triangle. What type of triangle do you think it is? Obtuse or acute? Raise your hand if you think it's acute. Raise your hand if you think it's obtuse. So is 74 less than or greater than 100? 74 is less than. But the biggest side is our c squared. So the c squared is greater than the rest of it. So what do you think it's going to be? Obtuse. Good job, Lauren. So remember, focus on which one's the bigger one. If the c squared is the bigger one, it's obtuse. If c squared is smaller, it's acute. So since c squared is the greater, it's obtuse. All right, let's look at example 6. Tell if the measures can be the side lengths of a triangle. If so, classify the triangle as acute, obtuse, or right. How can we tell if they're the side lengths of a triangle? Which two are we going to add? 5 and 8. What's 5 plus 8? 13. Is 13 greater than 17? So can these be the side lengths of a triangle? No. So it's not a triangle. What if this 5 was a 10? Yes? Yeah. So let's make it a 10. So now we have 3 side lengths of a triangle. So what's our a squared? What's our a? 10 squared. What's our b? 8 squared. And what's our c? 17 squared. And we knew that 17 was going to be our c because it's the biggest one. So what's 10 squared? What's 8 squared? And what's 17 squared? 289. So what's 100 plus 64? 164. Is 164 greater than, less than, or equal to 289? It's less than. So since the c squared is bigger than the other two added together, what type of triangle is this? Obtuse.
Why did you scratch out the 5 and put a 10 under it?
Because the 5 didn't work as a triangle. So 5, 8, and 17 were not the side lengths of a triangle. So I made it to be 3 side lengths of a triangle. So I changed the 5 to 10. So this goes with this. But 5, 8, and 17 were not the side lengths of a triangle. So I had to change the 5.
You had to solve it that way? Like, when you just do it as an example?
I just did that as an example.
Oh, okay.
Since it didn't work, I made it work. Okay, so it was just an example. Okay, last example. Tell if the measures can be the side lengths of a triangle. If so, classify the triangle as acute, obtuse, or right. So how can we tell if it's the side lengths of a triangle? What do we need to do first? Add what? What's 3.8 plus 4.1? 7.9. So is 7.9 greater than 5.2? So do these work as a triangle? Yes. So now we can tell whether the triangle is acute, obtuse, or right. So what is our A going to be? 3.8? So 3.8 squared. What's our B? 4.1 squared. And what's our C? 5.2 squared. How did we know 5.2 is going to be our C? Because it's the largest. So what's 3.8 squared? 14.44. What's 4.1 squared? 16.81. And what's 5.2 squared? 27.1404. You guys will not have decimals on your quiz. But since you have a calculator in front of you now, I know you guys can do this. So what is 14.44 plus 16.81? 31.25. So how does that compare to 27.04? 31.25 is greater than. So our C squared is less than the other two added together. So what type of triangle is this going to be? Acute. So that is 5.7. So when's your quiz? Monday. And your quiz is going to be on simplifying radicals, what we did yesterday, which was the hinge theorem, and the Pythagorean theorem, what we did today. So just these 3 sections.